Imagine this. It's the dead of winter, the sun has disappeared behind endless skies of gray, and the temperature has plunged to a bone-chilling minus 30 degrees F. You're not wrapped up in down jackets or insulated boots. No, you're wearing nothing but wool leather and your own stubborn Viking grit. The wind is howling like a pack of wolves, and just a breath outside your door feels sharp enough to freeze your very soul. Yet somehow, inside a wooden hall nestled deep in Scandinavian wilderness, the warmth doesn't just survive, it thrives. How on earth did the Vikings manage to create a complete workshop without a single power tool, in a world that looks more like a frozen wasteland from a fantasy novel than a place to build anything detailed, let alone a longship or intricate carvings? You might assume they did it with brute strength alone, or that they silently cursed a lot while hacking away at the ice with nothing but bone and stone. But that would be giving them way too little credit. Believe it or not, these Norse craftsmen were the original masters of off-grid technology, inventing clever setups that we still find shocking today, especially since they managed all this without electricity, pneumatic drills, or even the humble screwdriver. This might be the strangest Viking survival trick of all. Their workshop was a perfectly engineered machine in its own right, designed to work with nature, not against it. Think about it today. When we want to build something, we run to the nearest home improvement store, grab our electric drill and punch a few holes in minutes. The Vikings, they built entire ships, homes, and tools with nothing but hand tools, wood, fire, and some very smart environmental hacks. So, how did these legendary Norsemen pull it off? How did they create their own power tools out of thin air? Let's click into the Norse time machine and uncover their master class in ancient engineering. First, picture stepping inside a Viking workshop. It's not some dark, cramped cave filled with rusty spoons and half-finished stools. No, it's a surprisingly bright, warm space carefully crafted to survive the merciless Scandinavian winters. The walls stand thick and solid, not just layers of wood, but a carefully sourced mix that scientists today compare to nature's version of Gore-Tex. Yup, that cozy, breathable fabric that keeps modern mountaineers dry and warm. The Vikings had an ecological equivalent, their secret weapon, a remarkable technique called turf wall construction. They stacked blocks of dense, sod-covered earth as insulation, sometimes up to 2 feet thick, combined with pine wood beams treated with natural resins. The turf wasn't just a dirt pile. It was an ancient hot water bottle, trapping the workshop's heat inside even during brutal nights when the thermometer plunged well below minus 20 degrees F. Think about that. It's like wrapping your entire building in 1,000 layers of thermal blankets. To add to that, the Vikings cleverly positioned their workshop near natural heat sources. Imagine sinking your chisel into the wood, and just a few steps away, a fire pit filled the room with gentle warmth. But this was no ordinary fire. The Norse used peat, a slow-burning, energy-rich material made from compressed plant matter that would smolder quietly for hours, creating a steady 70 degrees F environment even when frost hovered just outside the door. It's like running an ancient 1,000-watt heater, except their fuel was harvested from the very ground they built on. But all that warmth would vanish without proper ventilation. Here's where it gets really interesting. The Vikings engineered a system so advanced that medieval carpenters would have sworn it was magic. Imagine vents carved into the walls and smoke holes, crafted with precise angles that funneled fresh air in and toxic smoke out, all powered by just the shape of the roof and some subtle airflow patterns. This might sound simple, but many modern green buildings working to use natural ventilation still struggle to achieve the same effect. It was breathable, warm, and remarkably well lit, thanks to clever window placement without glass panes, using thin animal hide stretched taut to keep out drafts. So turf and peat fires gave them warmth, and smart airflow kept the air fresh. But wait, what about the tools themselves? How did they dig into the wood, carve intricate shapes, or assemble their famous longboats without a drill, jigsaw, or power saw? The answer holds more surprises. The Vikings mastered a suite of hand tools that worked so efficiently it defies common sense. They combined iron and bone to create sturdy chisels and adzes, sharpened repeatedly using water-powered grindstones, a technology that might remind you of modern electric sanders but powered by the rush of rivers. Picture this: A quiet stream outside their workshop fuels a wheel turning day and night, and the constant motion sharpens their tools with the precision of a laser-guided blade. That's right, the Vikings used water to sharpen their tools well before electricity was an idea. It's like having a natural mechanical workshop in your backyard. And their chisels weren't just blunt bits of metal. They were forged from high-quality wrought iron, hammered, heated, and folded meticulously to create edges strong enough to cut through dense oak. The stroke of an adze or chisel might seem slow compared to modern machinery, but these tools allowed a surprising level of control. Think of it like using a scalpel instead of an axe. The result was finely carved wood, smooth surfaces, and precisely cut joints. Every notch and groove was planned down to millimeters, and without modern measuring tapes, the Vikings used remarkably accurate methods like calipers made from bone or simple geometry drawn on wood. But even with water-powered grindstones and perfect hand tools, assembling large wooden parts was no small feat. How did they handle massive planks without cranes or forklifts? Enter the ingenious use of mechanical advantage. Levers, pulleys, and winches crafted entirely from wood and rope. They built giant tripod frames to lift heavy ship components, using thick ropes twisted from animal sinew and plant fibers. These systems multiplied their strength 4 or even 5 times, a medieval version of today's hydraulic lifts. One standout invention was the Viking block and tackle system, a simple pulley arrangement that allowed even a few strong men to hoist beams weighing hundreds of pounds. Picture pulling on a rope so effortlessly that a massive, water-thickened log feels like a feather in your hands. And rope, it wasn't nylon or polyester, of course. Vikings created ropes from twisted animal hides and local plants like hemp. These ropes were so durable that, according to tests, they could withstand loads up to 3,000 pounds before snapping. That's about the weight of a compact car, pretty serious stuff for a string made by hand. But here's the kicker. Despite all these natural power tools and clever lifting contraptions, the Vikings never lost sight of quality or detail. The joinery on their ships, it was waterproof, flexible, and strong enough to withstand the violent North Atlantic waves. They used natural tar from pine trees, a sticky, waterproof glue that sealed seams better than many modern composites. So imagine the workbench again. There's careful stacking of beams, perfectly carved oars lying nearby, fine detail work going on with bone chisels, and the steady hum of the water wheel, spinning a grindstone outside, all within a wooden hall bathed in soft, peat fire warmth and protected by 2-foot-thick turf walls. This wasn't a primitive shack. It was an all-in-one natural factory in the heart of what we'd consider one of the harshest climates on Earth. But even with incredible tools, warmth, and ingenuity, the Vikings had to work fast and smart. Wood left outside could freeze solid in minutes. Fractures could happen when temperatures dropped suddenly by 40 degrees F overnight. To prevent this, craftsmen timed their work by the sun and moon cycles, working mainly during the late morning when temperatures peaked between 30 degrees F and 40 degrees F, even in winter. It's like scheduling your workshop output around the daily forecast. But their weather apps were actually deep knowledge of cloud patterns, wind, and animal behavior. And it didn't stop there. To keep wood from cracking, they stored planks and lumber inside the workshop for drying, in insulated racks that kept moisture levels between 12% and 15% optimal numbers to prevent brittleness. Today, woodworkers spend millions on controlled drying kilns, yet the Vikings achieved this balance simply by stacking and covering lumber with animal skins and moss. This kind of biological insulation is another Viking secret. Moss wasn't just thrown on for decoration. It was the medieval version of bubble wrap, insulating with tiny air pockets while also wicking away moisture to prevent mold buildup. Imagine punching holes in a modern air-cushioned bubble wrap parcel. Now swap plastic for green moss and you're halfway to Viking flooring insulation. So here's what we've uncovered so far. Vikings engineered a workshop that's warm as a sauna, naturally ventilated like a smart eco-home, powered by flowing rivers, heated with ancient renewable fuel, and loaded with handmade power tools crafted from earth, wood, bone, and fire. Every element worked in visible harmony, proving that technology isn't only about electricity or machines. It's also about design, materials, and pure human ingenuity. And this was all centuries before the first power drill or factory assembly line. They built ships that sailed oceans, furniture that lasted lifetimes, and tools that fit perfectly in their hands, all without a single plug or gadget. But here's the question. What happened when those workshops had to move, or when materials ran low? How did Vikings adapt their techniques on the fly while crossing new lands and rushing to build fast before harsh weather arrived? That's where their true genius shines even brighter, because their tool workshop wasn't just a place. It was a mindset that turned nature and necessity into innovation. Hold on tight, because in the next part, we'll dive into the specific tools they invented, the way they sourced iron from bogs, and the surprising Viking jigsaws that could rival modern power saws in precision. Plus, we'll meet the unsung hero, the Viking tinker who combined art and engineering like no one else. Ready to see how they cut, shaped, and assembled without ever plugging in? Stay with me as we unlock the next level of Viking craft mastery. Now, imagine the Vikings face the next big puzzle: how to create complex, precise cuts and shapes without a single metal saw blade spinning at thousands of RPMs. It sounds impossible, right? But here's the Viking surprise. They didn't just settle for hacking slabs of wood with dull axes or blunt knives. Nope. They invented a cutting-edge tool that in many ways worked like a hand-powered jigsaw. Picture a small frame saw, no bigger than a modern hacksaw, but crafted with razor-sharp, twisted iron blades set into a wooden frame. They called it a bow saw, and it was their secret weapon for everything from shaping ship ribs to fine furniture. What's wild is how the rhythmic, back-and-forth sawing action combined with ingenious blade tension made the job smooth and surprisingly fast, almost like tuning into a natural vibration frequency that woodworkers today are just beginning to understand. In fact, modern sustainable woodworking still uses bow saws in traditional settings because they cut so cleanly without power. No dust clouds or loud motors, just the satisfying scrape of wood fibers parting under precision tools. But shaping wood wasn't enough. Joining those pieces tightly was an art and a science. How did Vikings pull off joints that were watertight and robust, especially when building ships meant to survive freezing storms in the North Atlantic? Their secret lay in an ancient technique called log-lap joinery, combined with complex wooden pegs known as trunnels. These pegs, roughly the diameter of a pencil but twice as long, were carved from flexible hardwoods like ash or oak. When driven into pre-drilled holes, they swelled slightly thanks to natural moisture, kind of like how a cork plugs a bottle, locking beams together with a grip stronger than many modern fasteners. Think of it like natural superglue without the glue. And because no metal nails were used to avoid corrosion, these wooden fasteners could flex and breathe with the wood as the seasons changed, preventing cracks and leaks. To drill the holes for trunnels, the Vikings again relied on mind-blowing ingenuity. The bow drill. Similar in concept to the bow saw, the bow drill used a string tied to a wooden spindle, which was spun rapidly between two pieces of wood by moving a bow back and forth. The friction generated enough heat and spin to bore neat, circular holes through dense timber. Picture this: a simple hand tool that essentially mimics the spinning action inside a power drill, but controlled entirely by human energy and the clever leverage of a bow. It might sound like it would take forever, but practiced craftsmen could drill holes in mere minutes, ready perfectly sized for the trunnels that sealed their longships. And if you think that's impressive, wait until you hear how they made nails when they did need metal fasteners. Iron was scarce, even precious, so Vikings didn't just buy it off a shelf. They produced it themselves from bog iron. Yes, bog iron, a unique form of ore harvested directly from wetlands where iron minerals precipitate naturally. Imagine miners dipping deep into marshy, muddy grounds, pulling lumps of rust-colored ore from waterlogged soils that had lain there for centuries. Then, in open hearths fashioned from clay and stone, they turned this raw material into malleable iron through ancient smelting forges, operating at roughly 1,200 degrees C, without any electric furnace assistance. It was slow, smoky, and exhausting work, but the reward: iron so pure and flexible that blacksmiths could hammer out thin rivets, blades, and nails exactly tailored to their needs. This close-to-the-earth metallurgy is almost like an organic factory, turning water and earth into tools and weapons. Moving from materials to motion, Viking workshops didn't just invent natural power tools, they harnessed natural energy in other unexpected ways. Remember that water-powered grindstone we talked about earlier? The Vikings didn't stop at sharpening tools. They took advantage of seasonal river currents by building small wooden sluices and channels, essentially mini water mills, that converted flowing water into rotational energy used for multiple purposes. Besides grindstones, these water wheels helped power bellows for their forges, pumping air hot enough to maintain fiery temperatures needed for smelting iron. Think of it as a self-sustaining fuel blower, centuries ahead of its time, powered not by coal or diesel, but by the ancient force of moving water. The precision and durability of these systems are almost hard to believe, especially considering they were etched from raw timber, balanced with stone, and maintained by hand. As winter crept in and daylight hours shrank, you might wonder how Vikings managed to keep their workshops well lit without modern bulbs or even candles as we know them. Here again, innovation ruled the day. Rather than relying on flickering wax candles, which were expensive and smoky, they turned to simple oil lamps fueled by whale blubber and fish oil. Imagine a shallow stone bowl holding thick, tar-like oil that burned steadily with little smoke and a steady glow. These lamps, paired with polished bare fat torches, created a surprisingly bright working environment that reduced eye strain during the long winter months when daylight was scarce. Their clever use of reflective metals, like polished bronze mirrors, helped bounce this light around dark interiors, turning the workshop into a glowing hive of activity. Think of it like nature's version of LED lighting, low wattage but incredibly efficient given their resources. But here's where Viking workshop mastery truly matched modern ingenuity. The tinker, or smith, wasn't just a worker. He was a creative engineer, artist, and problem solver rolled into one. These craftsmen understood materials not just as tools to shape, but as living partners in their work. The same wooden plank wasn't a rigid block. It was a flexible frame that changed with temperature and humidity, needing adjustments and fine-tuning. Imagine a warship builder kneeling to test the bend of an oak plank, or a carpenter tasting wood, shavings to judge moisture content. This deep intuition, what we might call material literacy today, allowed the Vikings to innovate on the fly. When a tool broke or a plank warped, they didn't panic. They adapted, reinvented, and evolved their techniques with the resilience of engineers in the harshest startup ever. In fact, many of the woodworking tricks pioneered in Viking workshops have been rediscovered by modern sustainable builders, emphasizing natural materials and low-energy processes. From cross-laminated timber beams to traditional joinery that outlasts many modern glues, the Vikings' hands-on understanding still inspires architects and craftspeople worldwide. Their legacy isn't just in shipwrecks or museum relics. It's in how humans can build, adapt, and thrive with minimal environmental impact and maximum respect for natural cycles. Imagine wrapping up a long day in this ancient workshop. The peat fire humming warm, the rhythmic scratch of a bow saw in your hands, water from a nearby stream spinning the grindstone, and the smell of freshly cut pine mingling with whale oil lamps. Every beam, nail, and joint tells a story of centuries-old determination and craftsmanship that rivals, and sometimes outperforms, today's fast-paced, power tool-driven world. So, what can we learn from Vikings now? Their workshop teaches us that real power tools don't need electricity. They need creativity, respect for nature's forces, and a relentless spirit of problem-solving. They remind us that building something meaningful is not about speed alone, but about patience, precision, and connection, to materials, to surroundings, and to purpose. Every plank hammered and every ship launched was a testament to human resilience. It was about protecting families from winter's wrath, ensuring a lasting legacy through voyages and settlement, and mastering the art of turning scarcity into strength. Their workshop was more than a building. It was a crucible of innovation, endurance, and art, a place where power tools were born not from engines, but from human ingenuity and cooperation with the harshest environment on Earth. And that, in the end, might be the greatest Viking invention of all. The ability to build a complete, thriving workshop without a single electric tool, thriving not in spite of nature's challenges, but because of them. When you feel that cold snap or find yourself struggling against a difficult project, remember, Vikings stood where you stand now. They faced far worse and created wonders with what they had.